The objectives for the certification exam state that you need to be able to write a program that converts arrays to and from a collection and sorts the elements in the collection and performs a binary search on the collection and on the array. There are thousands of ways of doing these things, and I've written a program that shows you one approach. This program uses an array of string objects. The string class implements the comparable interface, so the compare-to method is available for comparison, and it's easy to display things when you need to print out just where you are with this stuff. This program stores the sorted list of strings in an array list object. Now this program is in 4 steps. Each step is in its own method for clarity. First, it sorts the information from the array and stores the result in a list object. Then the program uses a binary search algorithm to locate one particular string in the list. The list is then converted back to an array. This time the array comes out in sorted order. Finally, another binary search is executed to find a particular element of the array. The first task is to convert the unsorted array and create a list object of sorted elements stored inside the list object. Let me say again that there are thousands of ways of doing this. This may not be the best way, but it's a way that works. The first thing done here is the creation of a tree set object. This is used because things can be added to it in any order, and they'll come back in sorted order. Here, in this loop, each string from the array is added to the set, and the tree set inserts each one into a tree so they can be taken back out in sorted order. The next thing done is the creation of an array list object, that is to be the list that keeps things in the order in which they were entered. An iterator object is extracted from the sorted set, and this loop is executed once for each element in the iterator. The strings all come back in sorted order, and each one is inserted into the list as it's returned. Now, there, the task is done. We now have a sorted list. The search list method searches through the sorted elements of the list object to find a match. A binary search is used. This particular binary search algorithm comes right out of the original K&R book that defines the C language. There are several ways to write a binary search, but this is the best one that I know of. It starts off by setting the index values to the first and last elements to be searched. As long as these two numbers haven't crossed one another, the search is still underway. The element to test against is the one that's halfway between the highest and the lowest. And this is where the first comparison takes place. If the result of the comparison is less than 0, it means that the item being sought is somewhere before the midpoint of this list, so the high point of the list can be adjusted up to the midpoint for the next time through the loop. On the other hand, if the comparison shows that the item is somewhere beyond the midpoint, the starting value is adjusted to the position just after the midpoint. If the comparison is 0, the element has been found and we have its index. Now this loop closes in with the high and low values becoming closer and closer together until the midpoint is found, or it turns out that the element being sought isn't in the list. Converting the contents of the list object into an array turns out to be the simplest task of all. It's done with one method call. For some collection classes, it may be necessary to do this with an iterator and copy the elements into an array one at a time, but this list happened to have a method that just does it. This example just writes over the top of the original array, but you could store the produced array anywhere you wished. And here's the method that performs the final step, a binary search looking through the array for a match. Now this binary search algorithm is just exactly like the previous one. The only difference is the elements to be checked come from an array object instead of a list object. You can find several different ways of doing this by looking through the collection classes and checking the methods for the things that they can do. And that would be a good idea because you're quite likely to be asked to do something like this on the exam. In general, you need to be familiar with the container classes because they're used quite a lot.